Hello and welcome to Advent of Code. It's Christmas Eve here in California, and we're just waiting for the next problem to become ready. Got about 12 seconds left to go. Very exciting. Only two more problems left, and let's see what they've got for us. All right, CPU, a bridge, 2 ports. Okay. Components. Each port has a number of pins. More pins is a stronger connection. Okay, so number of ports. Your side, all right, 0 pin port. First port is type 0. The strength of a bridge is the sum of the port types. So if you have these components, you can make the following bridges. 10. One. Order of ports. Okay, so you can swap the ports around. Use each port once. The strongest bridge you can make. Okay, so let's see. Does the bridge have to end with a certain thing? I don't see that it has to here. All right. So you have to start with a 0. All right. So let's talk about reading this in. So each of these lines is going to be maybe like split the line on this and then map read string to it, giving us then something like this. Let's see. So it doesn't like the way I started. Oh, no, this is fine. Let's see. Split line on a slash. Does it need to be here? Okay. Let's see where we're calling replace on this thing here, but so 50, 41. This. Okay. Well, yeah, why don't we just do a split of this on new lines here, and then make sure our parsing function works. Okay, that's why. All right, very good. All right, here we go. So the following valid bridges. Okay. The sum of the port types. Strongest bridge. Okay. So I think let's see. How could we do something like this? So the starting points, let's see. So actually, we probably want to maybe represent this as set here. I think this is a little bit better. Okay. So, and then it's kind of like a search problem. So, given the links that we have so far, and latest and links and are links, then we might want to do something like valid states to go in are going to be like filter. Okay, so we might call this like, so we might have map P to this, define these to be our connectors. Okay. All right, looks good. And then, okay, actually, our state is also going to have the connectors in it. Okay, something like the connectors and links here, and then maybe, okay. And what we're going to do is we're going to iterate, so for AB in connectors, then let's see, so something like when equals, so let's see, the latest, I'm going to represent as like CD, like this. So when it's the case that B is equal to A, or D is equal to B, something like this, then we kind of want to emit a state where we like disj, so like we take state, update connectors by disj on AB, and update links by conj on, and then this is basically like if equals EA, then we need to conjoin D to C. Nope. A to B, like this. Otherwise, B to A. Okay. So these are the valid moves here. So if we talk about valid moves for connectors, when links is just an empty list, what are we talking about? It says you can't do an nth on a hash set. Interesting. Okay, well then I think we can just do like, nope, that's not it. I think you have to do like something like this. Right, this lazy sequence can't be cast. Okay, so that's in this case, so connectors, yeah, okay, so this needs to be a set here. Okay, so this is saying, okay, map, okay, I want to see the links that are being produced here. All right, so not exactly right. I think that so this has got to be like or D0 like this. Okay. All right. So this is starting to look good because I bet 0, sorry, like 17/0 is in here. Okay. The trick is that we're actually reversed here. So this needs to be instead of AB, I think B be A like this, A, B like that. Okay. All right. So this looks pretty good. Now we have to just do like a traversal here. So I think I have a BFS. Let's see if something like this will work. So basically look for the valid moves. All right, so how do we know that a state that we're in is going to be final? So basically the state that we're in is final if we can't go, if there are no more connectors, if the valid moves is empty. So so I think we say like something like if seek nodes, then we can do this recursion here. And otherwise, we want to return maybe like the score. It's a strength of this. So this is going to return I guess we can have it return a list of scores. So if there's nowhere left to go, then we just have this return a list of the score of links. Okay. And score of links to be apply concat to links and then sum score of a list. Okay. Yep. Okay. Now, maybe BFS is not quite right here. Well, if I, yeah, I think that this is maybe not quite right. So I do know that I need to call valid moves on the state here, and then maybe something like map. So this is going to be returning, so let moves be this. If this, then return the score of links, or sorry, if not that. Otherwise, I guess mapcat BFS to moves here. Okay, recursive definition, comment this out. Okay, so it's not really BFS anymore, but let's try taking a starting state, calling BFS on it, and then apply max key to the things that come out. Stack Overflow. All right. I believe it. All right. So can we change this to something iterative? Probably. Edge is like this. Let the moves be like the first of edge. If there's nothing left to explore, then we'll do something else. moves in E. All right. Okay, max score starts at 0. If there are moves left to do, then we want to recur on okay, EE and just leave max score the same. Cat EE moves like this. If there are no moves available at this edge, then we want to recur on EE and then take the max of max score and the score of the current point that you're at. And then otherwise return max score. Mismatched argument count, it says. Yep, okay, this needs to go up here. All right. Okay. It's cranking. Stack overflow. What? I'm surprised by the stack overflow here because I don't see valid moves doesn't call valid moves, right? Can I print the stack trace? First, map, valid moves, okay. Map seek connectors. Take a look at all the connectors. Well, we could F this to see some behavior here. Oh, that was not smart. Okay, what's the max score achieved so far? It says 0. How about the count of this? Interesting. And we still get the stack overflow. Okay, so it says the links are going from this to this, this to this. Okay, so I think the disj is not working. And the reason is that this needs to be the set here. All right. Try it again. Keyword can't be cast to number. That's the change that update disjoin a set containing A and B. What? Okay. Okay, links is this list. This looks fine. Connectors is a set containing a bunch of sets. That seems fine. Okay, numbers add as a consequence of okay, as a consequence of calling score. All right, so apply concat to links. Let's get the links of the first of these. Call score on it. Okay, map score, map links to all of these. Huh. Okay, what is it? what is it complaining about? Numbers add when sum, when you're computing the score of the links. Okay. I don't know how to create a sequence from long. This is in seek from here. Is it because, oh, I see, because we're already getting the max score out. Okay, all right, have an answer. Not the right answer. All right, so yeah, I guess, maybe seemed reasonable. It's possible we're not computing scores correctly. Following valid bridges. Okay, so let's try. Okay. All right, so let's call this connectors 2. Okay, okay. And this is, interestingly, still cranking. Is it because, nope, it's not clear what the reason is here. Why do we have just 2 here? What? Oh, okay, so that's not good. Okay, so that's probably something that needs to be fixed. So basically, this parse thing is wrong. So yeah. Okay, so we can't use sets in here. This needs to just be like this here. And then does this produce, no, this produces the same answer. Duplicate key 2 in a hash set. Okay, what is connectors 2 now? All right, so this seems fine. Then create with check, set connectors 2. So that's fine. All right, and then somewhere in here, okay, so basically this, we need to talk about this list. Okay, 12, but it should be 31. Okay, so interesting. Huh. All right, so it found this one, 0 to 0 to 1, then this one, and then it seems to be saying that when you're in this state here, that there are no valid moves. That doesn't seem correct. Valid moves in, I think it's just going to be faster to reason about these as vectors. Okay. 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 All right. This is the one that we care about. Okay, links can be a list. That's fine. What are the valid moves here? It says none. But it should recognize that this is a possibility. So what's the problem? Round number of things passed to a 4. Okay, that probably is needed, but not sufficient. All right, so let's see. So CD, this was the link, and it's saying that basically in this situation, okay, this looks backwards again. This link needs to be, no, this seems fine. Well, okay, so it's, I think it's matching the wrong thing. So what am I doing wrong here? Nope. Okay, so CD is going to be the first thing in the links, and we are setting it up so that D is the one that has to be connected to. So either D is A or D is B. In that case, do this and then say if D, or maybe actually this needs to be in place. $31. All right, I like that. Now let's take out the print. Nth not supported on. Okay, I think I have to redefine. Nope, not like that. Maybe just like this. Stack Overflow on hash equals? I don't know. This is on a disj. I don't know. So it's here? That doesn't seem too right to me. Give this one more shot. The set that I'm working with isn't so big here. So here are the connectors. There are the links. And it's saying that hash equality is too much here. That if I call valid moves on SSS, that doesn't seem to be having a problem with it. In fact, it finds one valid move. Let's print this again and stare at it. So disj, disjoin, contains key, hash. Don't see the big deal here. All right. Okay, this seems more helpful. This is basically saying valid moves. Basically, okay, creating a sequence from seek from concat. Okay, so maybe instead of concat, can laziness help me here? I hope so. I don't think it will though, because the issue, yeah, the issue is, okay, so actually maybe I think if I go like this, then this actually might be better. It'll still do the same amount of exploration, but I think I'm going to be popping off the more recent stuff sooner, so it shouldn't grow as big. All right, let's try this. Right answer, rank 268. Okay, second part. It's not long enough. You have to jump the rest of the way. Of them, the one which uses is stronger. What is the strength of the longest bridge that you can make? Okay, if you have multiple bridges of the longest length, pick the strongest one. Okay, so we're going to have max length here as 0. And similar kind of thing when we're out of spaces to move. We leave max length the same. So this is going to be the max of max length. So let's just say, let C be the count of the links here. And then say, if C is greater than max, at least as great as max length, then we're going to recur C and the max okay, and otherwise actually this. Okay. This. That. Okay. Okay, and then this isn't quite right. We have to say if C is equal to the max length, then do this. Otherwise, we just want the score. Okay. All right. Here's an answer. Answer 226. Okay. Yeah, pretty cool. Let's talk about the problem. So in this problem, our input is a sequence of basically like connector pairs here, And the rules are that you have to start at 0, and then you have to pick a connector that has a 0 on it. And then you have to pick a connector that matches the other side of that connector. So it's kind of like dominoes. So basically, and then your score is going to be the longest or the strongest sequence that you can make before you run out of things to do. So my implementation was to write this function here. So I basically represented my state as a set of connectors and then the links that I had made already. And then the implementation was basically so I used a linked list for this, and I said, okay, take the thing that's at the front of the linked list, and then for each of the connectors that are still in the pool, when they match the last connector, or 0 if you're just getting started, then what you're going to do to the state is you're going to remove that connector from the pool of options, and then you're going to update your links to add in either like the domino in the front direction or the back direction. And I had some trouble getting this to work originally, and the main reason for that, I think, was that I didn't properly have this OR in there. So I think I had this backwards for a little while. Wrote a pretty straightforward scoring function, which I had a bug there because this operates off links and not state. And then I ended up calling this breadth first search, but I don't think it is. I think the Stack Overflow is a dead giveaway there. What kind of search is this? This is, I guess it's depth first. Yeah, I think after my modifications, it's depth first. So basically, we start in a situation where the edge consists of a single state, and then we're tracking the max score in part 1 essentially. And then so what we're saying is grab the first and rest of your edges here. If there is something in first, and do all this stuff. Otherwise, just return the max score. So this is basically just implementing a search over an entire space. So yeah, this is going to operate until there are no more. There's nothing more left in the edge set, which means that it's going to try every possibility. And yeah, so what I said is that whenever I'm in an edge case, it's always going to be beneficial to find another move. Like it's never harmful to add more connectors, no matter where I am. So basically, I say in the case where I do have more moves, then what I'm going to do is just basically recur in my loop here, where I add the new possible moves to the edge set, and don't worry about length and score yet. But in the situation where there are no more valid moves, then I'm done. And what I have to do then is basically recur and update the max score based on how far I got for this particular edge. So yeah, that's a pretty straightforward implementation. Interestingly, this concat, which I just sort of needed to basically combine the new edges with the existing edges. If I define it like this, then, which is for my purposes, it's logically equivalent. For my purposes, this actually results in Stack Overflow, and the reason is that concat is lazy, and what that means is that you just have a proliferation of stack frames where you're like sort of popping off the front of the list more slowly than you are adding stack frames at the end of the list. But what you can do to get around it is you can put the latest edges, which are going to be the ones that are sort of deepest in the stack. You can put those first here, and then you'll be popping off the stack sooner. So that ended up fixing it, and then that was basically the whole thing. So that was part one, and then part two, it was a pretty straightforward generalization of it, which is that basically what we're doing now is we're looking for the longest sequence of links where length is just defined as the count of links in the chain. But then it says that if you have two chains of equal length, then they still want to know what the max score is. So that's just some straightforward logic here, and it finished in. I could probably time this, but it seems like, oh, I don't know, 10 seconds, 20 seconds. Yeah, not too long in any case. So yeah, fun night. We've got 24 out of 25 days on our Advent calendar lit up here. It's very exciting. Looks like we're not making it onto the top 100 this year. To do this, we'd have to get. Well, let's take a look here. So we would have to get a little bit more than 200 points tomorrow, which is I think impossible, because even if we got first on both parts, then we'd come up just a little bit short. So that's too bad. But I think that we had a pretty respectable performance, and I'm looking forward to tomorrow's problem and Christmas Eve, and having a nice Christmas here. So thanks for watching, and tune in for the final installment tomorrow.